Hello students, welcome. Previously, lesson 4, form 2 topic 3, we were dealing with covalent bonds and we were using dots and cross diagrams to show bonding in some compounds. So today we are going to go to lesson 5, which we are going to see coordinate bond. The other name of coordinate bond, it is a dative bond. Learners, remember we said we have only 3 types of bonds. One of them is ionic bond, the other one is covalent bond, and the other one is called metallic bond. So know that coordinate bond or dative bond is not a type of bond, but it is just under covalent bond. So we start by knowing the definition of coordinate bond. And we're saying coordinate bond is a special type of covalent bond in which the shared pair of electrons forming the bond is contributed by only one of the atoms forming the bond. If you remember when we are dealing with covalent bonds, we said the shared pair of electrons forming the bond is contributed by the 2 atoms forming the bond. But when we're talking about coordinate bond, the shared pair of electrons forming the bond is contributed by only one of the atoms forming the bond. So we go and see examples. Number 1, we are told use dot and cross diagrams showing bonding in the following compounds. So the first compound that we have is carbon 2 oxide. When you see carbon 2 oxide, we're having carbon atom, and it is atom's energy level, which is linked with the oxygen atom, it is atom's energy level is that. So we can take carbon and we give dot, then we can have oxygen and we give it cross. So the electronic configuration of carbon is 2,4, the electronic configuration of oxygen is 2,6. Then we ask ourselves, for carbon to become stable, how many electrons does it need to accept? So 4 electrons is required or is needed to accept. So those 4 electrons will be obtained from oxygen, which is having cross. So we are going to put 4 cross in the shared part. That is the shared part. So we have put 4 crosses. So we go again, we ask ourselves, for this oxygen to become stable, how many electrons does it require to accept or to gain? 2 electrons. So those 2 electrons will be obtained from carbon, which is dot. So that means we are going to pick 2 dots and we put it in the shared part. Know that that is the shared part here, where we are going to have the linking. So next step, what we are supposed to do is we count the atom's energy level. So for carbon, it was having 4 dots. But how many dots do we have now? We have only 2 dots, one here and the other one here. So that means this carbon needs 2 more dots. Then we go to the one for oxygen. Oxygen is having 6 crosses, as you can see there. But now I see 1, 2, 3, 4 crosses only. So that means I'm supposed to have 2 more crosses on these 2 other parts. So now it's okay because oxygen is having 1, 2, 3, 4, 5, 6. Then it has gained those 2 dots from carbon. Then carbon is having 1, 2, 3, 4 dots. Then it has gained 4 crosses from this oxygen. So we're done the bonding like that. So let's just try to see the answer that we have written here. This is the answer. So this is carbon and this is oxygen. So as you can see, oxygen is contributing 4 crosses and also carbon is contributing now 2 dots. So that means when we are having 2 of different kind, 2 electrons, one is cross, one is dot, that's a covalent bond, as you can see here. So this one again, this dot with this cross, that's again a single covalent bond. But when we are meaning with 2 crosses like this, so those 2 crosses will form coordinate bond. So coordinate bond should have an arrow. So the arrow will come from the atom which contributed the 2 electrons to be shared, and it's going to be on the side of the atom which has not contributed any electron. So that means here we are having 4 crosses. So that means these 2 crosses are from oxygen because it's oxygen which we have given cross. So the arrow must come from oxygen and it has to head to carbon. So this is the other way that we can show the bonding of carbon to oxide. So we are going to go to part B, ammonium ion. So ammonium ion is written NH4 plus. So for you to do this linking, you have to know first of all, how is ammonium ion formed? Ammonium ion is formed when ammonia gas reacts with the hydrogen ion. So we know how ammonia is, it's having one nitrogen bonding to three hydrogen. So that's one hydrogen there. This is another hydrogen, and this is another hydrogen. So the electronic configuration for nitrogen is 2,5. So that means having 5 electrons atoms in the level. So let's just try to give nitrogen cross. So what does that mean? We are going to have one cross here, another cross here, and another cross there. Then we're having 2 more crosses. So in total, we're having 5 crosses for nitrogen. So we go to hydrogen. Hydrogen is having only 1 electron in its outermost energy level. So that's 1 dot there, then another dot in that other hydrogen, and 1 dot in this hydrogen. So remember, this hydrogen is hydrogen ion, and hydrogen atom was having 1 electron, and when it loses this electron, it's going to have 0 electrons with a positive charge. So that means here we are having 2 electrons which are lonely. So we call these ones lonely pairs. So that means that hydrogen with no electrons will be just sharing these electrons like that. So we are going to end up having the charge. That's we close here. We are going to put a positive charge like that. That's how you are going to do ammonium ion. But see, we are told hydroxonium ion, it's written H3O+. So for us to do this bonding, first of all, we have to know how is hydroxonium ion formed. It is formed when water reacts with hydrogen ion, the way we were doing ammonium ion. That's how we are going to do. So here we're having 1 oxygen which is bonding to two hydrogen. When we're talking about water, it's like this. Then when you're talking about water, it's having oxygen. The electronic configuration of oxygen is 2,6. So that means it's having 6 crosses in its outermost energy level. So we can put 1 cross there, another cross there. So I'm remaining with 4 more crosses. 1, 2, 3, 4. I'm done with oxygen. Then we go and see hydrogen. Hydrogen is having only 1 electron. So we can put 1 dot there, we can put another dot there. So that means this hydrogen has lost its electron already. That's why it's having a positive like that charge. So that means we can link 1 hydrogen in the lonely paired electrons, so that it is having the coordinate bonding there, or the coordinate bond. So that's how we are going to do hydroxonium ion. Then we are going to put the positive charge there. So these 2 more unpaired, lonely pairs remains like that. So when you check, this is how we have done. Next, we are in the extended question. Question 2. We are told use dots and crosses diagram show bonding in the following compounds. So we have only A, that's phosphonium ion. It's written BH4+. That's the end of our class today. Thank you for watching.